Hi guys, this is Mrs. Wheeler, and I'm going to walk you through lesson 12.7 on the effects of outliers. Open your book to page 499 while I cue up the video.
How does an outlier affect measures of center?
Okay, so today we're talking about outliers. Outliers are numbers that are different than the rest of your data sets. For example, if you got a 91 on one math test and an 84 on another math test and a 25 on your third math test, 25 would be an outlier because it is not close to the other pieces of data that are in your information set. That outlier will affect the mean, which is the average score. It'll affect the median, the middle score, and sometimes it'll affect the mode, the most repeated score.
Hey there! Some people flew kites at the park yesterday. It was fun to watch them. Don't you agree, Pamela? Some people were able to fly their kites very high in the sky. Let's check out the greatest height that each kite reached. Wow! It looks like one kite was 200 feet in the air. That is quite a distance compared to the rest.
Notice that most of the data points are around between 50 and 90 feet in the air, but 100 or 200 feet in the air is a lot higher than the other heights that were flown. So therefore 200 is called an outlier.
How do you think this one height might affect the mean of all the heights? We can learn how one value can affect the mean and median of a data set. Let's go.
Let's look at a set of data to determine if there are any outliers. Let's unlock the problem. An outlier is a value that is much less or much greater than the other values in a data set. Let's make a dot plot to help us find any outliers in this data set. Plot the first row of data found in the table. 7 of the data values are plotted on the number line. Plot the second row of data found in the table. 14 of the data values are plotted on the number line. Almost done. Plot the last row of data found in the table. That's it. Now all 21 data values are plotted on the number line. Did you notice that most of the data values are between 2 and 10? What about the value that appears to be much greater than the rest of the data values? 18 is an outlier for this data set. Let's look at a set of data to determine if the outlier affects the mean and median. Let's unlock the problem. Let's make a dot plot to help us find any outliers in this data set. This dot plot shows one dot for each value in the data set. Notice that most of the data are values from 41 to 45. For this data, the value 25 is much less than the other values in the data set. So the outlier is 25 degrees Fahrenheit. To see how the outlier affects the mean, we can find the mean of the data set without the outlier. The mean is the sum of the data values divided by the total number of values in the data set. Without the outlier, 25 degrees Fahrenheit, this set of data has only 6 values. The mean of the data set without the outlier is 42 5/10 degrees Fahrenheit. To find the median,
Notice to find the mean, you add up all of the data points and divide by how many data points there are. They added up the 41, 41, 42, 42, 44, and 45. They did not include the outlier. When they added those up, they got 255. They divided that by 6 to get the mean of the data without the outlier. The mean without the outlier included is 42.5. Notice above, it says that the mean of the data is 40 degrees when you include the outlier. So what happened to the mean when you included the outlier? The outlier caused the mean to go down because the outlier was far below the other data points, period.
Without the outlier, let's order the 6 data values from least to greatest. Since there is an even number of data values, the median is the mean of the 2 middle values. 42 plus 42 divided by 2 equals 42 degrees Fahrenheit. Now, let's find the mean with the outlier. The mean with the outlier is 40 degrees Fahrenheit. Compare the mean with the outlier to the mean without the outlier. 40 degrees Fahrenheit is less than 42 5/10 degrees Fahrenheit, so the outlier made the mean lower. Now let's find the median with the outlier. The median with the outlier is 42 degrees Fahrenheit. Compare the median with the outlier to the median without the outlier. 42 degrees Fahrenheit equals 42 degrees Fahrenheit, so the outlier did not affect the median.
You'll notice that if the outlier is far below the other data points, the mean will be dragged down in value. If the outlier was above the value of the other data points, the mean will be increased by the outlier, period. With the median, it is not so easy to tell. You have to actually list the numbers from least to greatest and check to see if the median changes when you include the outlier. Sometimes it will and sometimes it won't.
Here's some data about the number of shots a basketball team made. Find the outlier by drawing a dot plot of the data. To draw the dot plot, drag and drop dots to places above the numbers on the number line to represent each data item. When you're ready, check your work. That's right. A dot plot of this data has 3 dots above 1, 5 dots above 2, 3 dots above 3, 2 dots above 4, and 1 dot above 17. So, what is the outlier for this set of data? Correct. The outlier is 17.
If we found the mean of the data with the outlier, what would happen to the mean? If you said that the mean would increase because the outlier is higher than the other data values, you are correct. For each of the math problems in lesson 12.7, you will have to find the mean and the median, including the outlier and without the outlier, to see if either of those values are changed by including the outlier. If you have any other questions, please email me at andrea.wheeler@savsd.org. Thank you.